Well, now in this question is asking the molar solubility of cadmium hydroxide is 1.84 into 10 to the power minus 5 molar, and the expected solubility of cadmium hydroxide in the buffer solution of pH is equal to 12 he is asking, and there are the 4 options. Let's start the solution. So the solution will be, now let's find out the value of the KSP, because we know that if temperature is not changing, the KSP will not change, right? So the value of KSP will be equal to 4S cube, and S is the solubility, and that is given to us, that is 1.84 10 to the power minus 5. So we can write here it is 1.84 into 10 to the power minus 5 whole cube, right? Now in the buffer solution, the pH is equal to 12, right? It means that the pOH will be equal to 2, and OH minus concentration will be equal to 10 to the power minus 2 molar, right? And KSP will be equal to concentration of cadmium multiplied by OH whole square, and it will be equal to cadmium 2 plus into, now the concentration is 10 to the power minus 2, so it will be 10 to the power minus 2 whole square, and that will be the KSP we found just now. It is 4 into 1.84 10 to the power minus 5 whole cube. So it is 4 into 1.84 into 10 to the power minus 5 whole cube. Now we know that KSP will not change, that's why we have done this, and the value of the concentration of cadmium 2 plus, which is the solubility of cadmium hydroxide in the buffer solution, will be equal to, after solving we will get 2.49 into 10 to the power minus 10 molar, right? So let's check which is the correct answer. Yeah, this one. So the answer is option number 4, right? Let's move on to the next question. Now the temporary hardness of the water sample is due to the compound X. Boiling this sample converts X to the compound Y, right? X and Y respectively are the option given to us: calcium bicarbonate and calcium hydroxide, magnesium bicarbonate and magnesium hydroxide, magnesium bicarbonate and magnesium carbonate, calcium bicarbonate and calcium oxide. Now it's given in NCERT. It is magnesium hydroxide, which decomposes on boiling, and it will give us magnesium hydroxide. So the correct answer is option number 2, right? Let's move on to the next question. Now in this question is asking heating of 2-chloro-1-phenyl butane with potassium ethoxide in the presence of ethanol gives X as the major product. The reaction of X with mercuric acetate in water followed by the reduction with NaBH4 gives Y as the major product, and Y is, he is asking what is Y. Let us solve this. Now solution. Now this compound 1, 2, 3, 4. So it will be 2-chloro-1-phenyl-butane. So you can see it is 2-chloro-1-phenyl-butane, right? Now what he is doing, he is adding potassium ethoxide in presence of ethanol. Definitely elimination will take place, and in elimination we have to check the product should be stable. So this is the benzene ring, and if this will be the product, this double bond is in the resonance with the benzene ring, right? So that is a stable product. Now after that he is adding mercuric acetate in this. So this is CH3COO whole twice Hg and with water, and it is followed by NaBH4. So this is the first one, and in the second step it's doing this. Now this reaction is called oxymercuration demercuration, and in the case of the oxymercuration demercuration we get the Markovnikov's product, right? So if we will get the Markovnikov's product, the answer will be this. So it is 1, 2, 3, 4. So our answer is option number 1, right? Let's move on to the next question.